Welcome to class. I'm Samm. Today we're going to be treating logarithms, a very interesting topic. I'll make it as interesting as possible. Let's go. All right, so the first thing we'll look at is what is a logarithm? Now, a logarithm is just a way to find out how many times you multiply a number to get another number. You catch that? It is just the inverse of exponents. So we've covered indices. So now we're treating the inverse of it. Now, let's say you have a number 1000. Now, how many times are you going to multiply 10 by itself to get 1000? 3 times, right? Good. It means that the logarithm of 1000 to base 10 is 3. And that's what logarithm is. Yeah, that's what logarithm is. Now, you might want to ask, what's the importance or what's the use of logarithm? Is it really important? Yes. So, next question is, why logarithms? Now, logarithm is very, very important. Let me give 4 reasons. 1, logarithm can be used to solve complex exponential equations. Let's say you have 2 raised to the power x equal to 4. You can easily say 2 raised to the power x equal to 2 raised to the power 2, right? And then you equate the powers, you get your answer x equal to 2. And this is pretty straightforward. Now imagine you have 2 raised to the power x equal to 5. Now, there's no power to 2 that will give you 5. So equations like this that are a bit complex can be handled by logarithms. So we use logarithms to solve complex indicial or exponential equations. That's 1. Now 2, logarithm is used in scientific calculations like the pH of a solution. So if you do chemistry, you would have heard of it. Yeah, you can calculate the pH of a solution using logarithm. So you see something like this in your chemistry. pH, which is a measure of the acidity of a substance, equals to negative logarithm of hydrogen ion concentration to base 10. And this is the pH of a solution. So I said 1, indices logarithm is used for handling complex exponential equations. 2, logarithm is used for scientific calculations like the pH of a solution as I've just shown. 3, in computer science, we use logarithm to determine algorithms, time complexity. So logarithms is important in computer science. And finally, I said I'm giving 4. In finance, we use logarithm to calculate compound interest. Now let's begin. For us to understand logarithms very well, we need to understand the laws of logarithms. So we know how to apply them in different situations. So let's go to laws of okay. Yeah, before we look at the laws of logarithms, there are 2 types of logarithms. One is the common log, another is the natural log. Now, if you have, most of the times you see log, let's say log 2 base 10. Now this is a common logarithm. Now there are other kinds of logarithm. Let's say 2 base e. So now if the base of the log is e exponent, that's called the natural log. And instead of writing it this way, most times you see it this way, ln 2. So if you see ln 2, that's log 2 base e. So types of log, we have common log and natural logarithm. Take note of that. Now we move to the laws of logarithms. Now, if we understand the laws, just like indices, when you understand the laws of indices, you can solve problems easily under indices. So it applies to logarithm. If we understand the laws of logarithm very well, it will help us to solve problems. So let's look at the laws of logarithm. Okay, so I will run through the laws of logarithm quickly, and then we'll start using them to solve problems. Yeah, so laws of logarithm. Now the first law, we're going to call it addition law. It says if you have a log, let's say log A plus another log B. So when you are adding two logs of the same base, let's say base n. So if you have log A plus log B of the same base, you can do this log A multiplied by B, same base. So this is the first law of logarithm. This one should sync. A logarithm plus another logarithm having the same base, you can pick the logarithm and multiply the arguments of the log. So that's the first law of logarithms. Now the second law says if you have log A base n minus log B base n, you pick your log to base n, you divide the arguments. So the first law, when you are adding logarithms, you multiply the arguments. When you're subtracting, you divide the arguments. Now the third law says if you have logarithm, let's say log A to having a power of A, you're having a logarithm whose argument is A, but the argument is having a power of small a. Now you can bring the power forward and it gives you A log A. Yes. So these are the three basic laws of logarithm, but they won't be sufficient for us to solve all the problems. So we'll look at other rules that you can apply to solving problems involving logarithms. So let's do a quick recap. The first law, addition law, when adding logarithms of the same base, you multiply the arguments. When subtracting logarithms of the same base, you divide the arguments in this manner. And at the third one, if the argument of a log is having a power, A having a power of A, you can bring the power forward and then you have A log A. All right, so before we proceed, let's do one or two examples and then we proceed. So what will be the answer to that simplify log A plus log B plus log C? Log A plus log B plus log C. A second one, log A minus log B plus log C. Yeah, what will be the answer? A third one, log A plus log B minus log C. And the fourth one, log A minus log B minus log C. Okay? What will be the answers in terms of ABC and logarithm? What will be the answers to these four problems? So I'll give you 1 minute. Sorry, 1 minute is too much. I'll give you 30 seconds and then I provide the answers. I just really hope you get them correctly. Welcome back. So for the first, log A plus log B plus log C will give us log A multiplied by B multiplied by C. following this first law. So when you're adding, you multiply the arguments. Number 2, we have log A minus log B plus log C. That will be log A minus allows us to do what? Divide. Divided by B, right? Multiplied by C. So to put it clearly, we have log AC over B. So that will give us log AC over B. And if this is clear to you, number 3, without wasting time, will be log AB. C is negative, so C is divided. So AB all over C. And then the fourth one will give us log A is positive, B negative, C negative. So the negative ones go down, right? So we'll have A over B, C. Yeah, so I want to hope you got all the answers correctly. If you didn't, these are the correct answer to these 4 problems. All right, so let's proceed with other rules that will help us to solve problems effectively. So I will just continue 4, 5, 6, and so on. So rule 4. Now, if the argument and the base of a log are the same, the argument and the base are the same, it gives you 1, regardless of the value. So if the argument and the base are the same, the answer is 1. Another thing to note is that if you have log of 0, sorry, I mean log of 1. Log of 1, the answer is 0. We can prove this using the laws of indices we've learned earlier, but log 1 is 0. Okay? The next one, if you have log, let's extend this law 3. We're extending law 3. If you have log, say, A raised to power A, and the base B has a power of its own. Now, remember in this one, we'll bring the power forward, right? We'll do the same thing. We'll bring the power forward and the power of the base as denominator. Then we have our log A base B. So get the point clear. If the argument and the base both have powers, the way we resolve the powers is that we bring the powers forward, while that of the argument is the numerator, that of the base is the denominator. Very important. Now, a 7th one is if you have, let's say, n, a number raised to power log, let's say, a base n. Now watch. N is having a power of log a base n. Now, if the base of that log, which is the power of n, is the same as the number raising the log, as the base of the log and the number are the same, your answer is equal to the argument of the logarithm. Okay, so these are 7 laws that would help us to solve problems easily. Okay, if there's any other one I'm missing, I'll add it in the course of our solving problems. So these are the basic laws of logarithm. So let's do a quick recap. The first one says if you're adding 2 logs, you multiply the arguments. Subtracting, you divide the arguments. If the argument has a power, the power can be taken to the front. So you have a log a. as we've done here. Now, if the argument and the base of a log are the same, the answer is 1. Now, if the argument of the logarithm is 1, so long as the base is not 0, the answer is 0. And now, if the argument and the base have powers, just like law 3, we can move the powers to the front so that we have the power of the argument divided by the power of the base, then log, you have power and base. Now this one, if you have a number raising a number whose power is a logarithm, now if the base of that logarithm is the same as the number, then it will give you the argument of the logarithm. So anyone that is not here, as we solve when the problems come, we'll be able to pick out the law and then I'll add it to this list. All right, so with this now, we're going to solve a few problems involving logarithms.